So we'd like to learn how to calculate probabilities in the z distribution and the standard normal distribution. And we're going to do that using what we call the z-table. The z-table. Let me show you the z-table. So I have a document here of lots of different statistical tables. So you'll see it posted. You'll see it posted where we posted the cards, the playing cards in the binomial table in Sakai. So if you go to page 5, you'll see the negative z-score table. And if you go to page 6, I believe, you'll see the positive z-score table. This is the positive side of the z distribution. It's to the right of 0. It deals with positive z-scores. And this one, notice, is to the left of 0, so it deals with negative z-scores. Okay, so we're going to show you how to use that. So what I have here, I have z is the standard normal random variable. Okay, so z is the standard normal random variable. That means I'm dealing with the z distribution or standard normal distribution. I want to find the probability that, number 1, what's the probability z is less than 1.62? So I'm going to draw a little picture of my z distribution. So it looks something like this. Remember, here at the center is 0. That's the mean, right? That's the mean. The mean is 0. Now, where is 1.62? 1.62. That is a z-score that's positive, right? It's up here. So we want the probability that if I take a random z-score, it's less than 1.62. Where is less than? Less than is over here to the left, right? To the left. So we want z to be somewhere down here to the left. We want a random z-score to be less than 1.62. So remember what we said about finding probabilities. Probabilities, P's, are areas under these density functions. So I'm going to calculate the area here underneath this density function that's to the left of 1.62. So to do that, all you have to do is look up the number 1.62 in your z distribution table. Your table always reads from the left tail. So the area is coming always from the left in your table. So when I look up the number 1.62, it's going to calculate the area to the left always of that number I look up to. So in this case, it's going to be to the left of 1.62. So let me show you how to look that up. So I know I'm dealing with a positive z-score, right? 1.62. So I have to go to my positive table. And how do I look up 1.62? Let's see. Can I write on this? I wonder if this lets me write on it. It'd be nice if I could write on this. There it goes. Awesome. Okay, so I'm going to look up 1.6 here. Well, thought that was writing. 1.6, and I'm going to put this little O2 right there. So this is giving me a z-score. Z-score here is 1.6. O2 gives me 1.62. And then in the middle here of the table is going to give me my area to the left of 1.62. It's always going to be to the left of the z-score that we look up. So it's going to be to the left of 1.62, this area. So that area is the probability. It's 0.9474. 0.9474. So that's going to be our answer there. 0.9474. 0.74. And that's the area. The area is 0.9474. So that means you have a 94.74% chance of getting a random z-score smaller than 1.62. Okay, let's do a number 2. What's the probability of getting a random z-score less than minus 0.73? Let me draw a picture of that to represent that. We're dealing with our standard normal distribution, z distribution. It's bell-shaped, and at the center is 0. Now where's negative 0.73? Negative 0.73 is here to the left, right, of 0. It's a negative z-score. And we want our random z-score to be here to the left, right? We want it to be smaller than negative 0.73, so here to the left. So all I really have to do is find the area here under my distribution curve, my density function, my density curve, to the left of negative 0.73. Is that a 3? It doesn't look like a 3, it looks like a 5. Let's make it look like a 3. So let's find that area. Let's find that probability. So remember, to find the probability to the left of a number, you just have to look up that z-score in your table. So we're going to just look up the z-score, negative 0.73, in our table. So I'm going to my z-score table. Let's delete some of this. Am I in the right table? No, I'm not. Right, I'm on the positive table. I need to be in the negative table. I need to look up negative 0.73. Let's see if I can get this to move. Okay, it's moving. So where's my negative table? Is this the negative one? No, that's the positive one. Let's go the other direction. Okay, there's a negative one, right? We said we're going to look up negative 0.73. And if we look up negative 0.73, we'll immediately get the area to the left of that. So here we are. Okay, get my marker. So here's negative 0.7. It's not writing, there it goes. And we got to look up an O3 over top. Oops, that wasn't good. Where's the O3 over top? There it is. So when I put the negative 0.07, I'm sorry, the negative 0.7 with the O3, that's going to give me negative 0.73. So how does this thing work? It's not working, is it? Let's see if this works. Okay, so I'm going to go down here. I'm going to go right here. So I looked up negative 0.73 at my table, and this number is going to be the area to the left. The area to the left of that z-score, negative 0.73. So that's what? 0.2327. 0.2327. 0.2327. And that's what that green area is. 0.2327, just for emphasis. Okay. So that's looking up probability of getting a z-score, a random z-score, less than a number. What about greater than? What if we mix it up and say we want the probability of getting a z-score greater than a number? That adds a complication. What if I want the probability of getting a random z-score bigger than 0.31? 0.31. Let's draw a picture of that situation. So I have a z distribution. Zero's in the center, right? Where's 0.31? 0.31, well, it's positive, right? It's a little bigger than 0, 0.31. And I want my z-score, random z-score, to be bigger than 0.31. So if it's bigger, it's somewhere up here, right? Z has to be up there. So my probability isn't going to be to the left. My probability, my area, is going to be up here to the right. Now, what would happen if I just looked up 0.31 in my table? What would happen? If I looked up 0.31 in my table, I wouldn't get that green area, right? I'd get the area to the left. I get this yellow area. So I don't want to look up 0.31 in my table. If I do that, if I look up 0.31 in my table, it's going to give me the area to the left of 0.31, the yellow, not the green. So we have to think of another strategy. So what we can do, we can play a trick. We can flip this graph around. Let me show you what I mean. We can take this graph and flip it around. We can put negative 0.31 on this left side, and we can look to the area to the left. Put the z-score to the left and look at this green area here on the left tail. Rather than the right tail, we can look at the left tail. So notice that this green area here to the left of negative 0.31 is the same as this green area to the right of positive 0.31. That's because that the z distribution is symmetric. So this is equal to probability of getting a z-score less than negative 0.31. What have we done? We've basically flipped the inequality, right, and changed the sign. So that's all justified by this picture here, the second picture. The second picture we drew is justifying that step. So now, all we have to do, we have to look up negative 0.31, right? Because in the second picture, if you look at the second picture, we're coming from the left tail now, right? From the left side. So look up the z-score, negative 0.31, and you'll have your answer. So here I go. I'm going back to my table. Where's negative 0.31? If I can get this to work here. Okay, negative z-scores, right? That's what we want, negative z-scores. And we want to look up negative 0.31. So here's negative 0.3. And I believe over the top, here's the 0.1. Zoom out a little bit. Put these together. So here we go. Negative 0.3 with the 1. So you get an area here of 0.3783. 0.3783. So literally, that's the area here in this left tail, 0.3783. That's equal to the area. Right? And that's the same area as in that right tail, right? The left tail is the same as the right tail. Okay, so that's a little trick you can play when doing the greater than type. Let's do another one. This would be a number 4, I guess. What if I wanted the probability that z is greater than negative 1.41? So if I draw a picture, I have a z distribution. Zero's in the center. Negative 1.41. It's the z-score we're interested in. That's here on the left side of 0, right? It's negative 1.41. But we want a z-score bigger, right? Z-score here to the right. That means we want this area here under the curve, under the density function here to the right. Of course, if you were to look up negative 1.41 in your z-score table, you get this area here to the left, right? You don't want that area to the left. No, sir. No, ma'am. No, friend. You want the area to the right. So what we can do, we can flip this around. We can take negative 1.41 and we can flip it over here to positive 1.41. And we can look at, rather than the right tail, we can look at the left tail. We can find the area under our density function to the left, right, of 1.41. Z. Right, we want z now to the left of positive 1.41. So here, to the left of 1.41 is going to be the same as here to the right of negative 1.41. So how do we write that? That's going to be probability of z to the left here, right? Smaller than 1.41. So literally what I've done, if you just look at the pure symbols, I've flipped the inequality and changed the sign to a negative, or to a positive, from a negative to a positive. So now that I'm dealing with z is to the left of a positive 1.41, I can just look up 1.41 in my table and find the area to the left of 1.41. So let's look it up. There we go. So I'm going to be dealing with the positive table, right? The positive table. Here's the positive table, 1.41. So I'm going to look up 1.4 and 0.1 there. I'm going to put these together. Just do a little zoom here just for fun. There it is, right? 1.41. When I look up that number, it's going to give me the area to the left of it. It's 0.9207. 0.9207. Oops. So that's going to be my answer, 0.9207. So roughly a 92% chance of getting a z-score greater than negative 1.41. Yep, so that's the area in there. You don't have to draw all these pictures like I am, but I'm just doing it for emphasis sake.